The great white shark is 400 million years and 6,000 pounds of muscle compressed into a single mechanical function: locate and accelerate, then bite and release. It is the default villain of every ocean documentary. The bite force and speed is real. But three other organisms don't operate on that model. They don't kill and move on. The tongue-eating louse will enter a host, remove a functional organ, and replace it with itself. The sea lamprey will lock onto a host and calibrate its extraction rate to keep the resource alive indefinitely. The sarcastic fringehead will open its jaw wider than its own body and hold territory without a single lethal event. Dominate, feed, replace. Three distinct failure modes, same conclusion. The shark is the least efficient system in the water.
A diver moves along the California seafloor, scanning for anything interesting. They pass a discarded glass bottle half buried in sediment, standard debris. Then they get too close to it. Something comes out of the bottle. Not a full body, just a jaw. A jaw that opens wider than the fish attached to it should physically allow. Needle teeth along the interior margin, fringed tissue around the orbital rim. The mouth is larger than the head. The head is barely 3 inches long. The diver backs up. The jaw attracts them. No venom, no charge yet. Just the display, held open, locked on, waiting for the next move. That is Neoclenus blanchardi, the sarcastic fringehead. The name comes from the Greek sarkazein, to tear flesh. 12 inches at maximum length, lives in discarded shells, bottles, cans, any cavity it can occupy along the California coast. From the outside, a marginal organism. From the inside of its bottle, it is the only organism that matters.
The jaw display is not a feeding posture. It is running a threat assessment protocol. The intruder leaves or the display escalates to a charge. The size of the intruder is not a variable the fringehead factors into the response. Shelter along this coastline is scarce. Think of it as a real estate market with one property, 0 landlords, and a standing eviction policy enforced entirely by jaw. The fringehead's entire survival model depends on holding the one space it occupies. It has evolved a display so disproportionate that the calculation for any intruder becomes simple. The cost of engaging is higher than the value of the cavity. The intruder vacates. The fringehead never had to leave its bottle to win. 0 lethal events. Territory held indefinitely. 2 more organisms. One of them has been inside the same host for 3 years, and the host doesn't know. Subscribe to Apex Vault if you want to see how the variables resolve.
A biologist lifts a lake trout from a survey net and sees a second body attached to the flank, smooth, cylindrical. They take hold of the parasite and pull, and the trout moves with it because the mouth is sealed down like a suction tool. When it finally comes free, it leaves behind a near-perfect circular wound, still draining. One sea lamprey kills approximately 40 pounds of fish across its parasitic lifetime, not through a single attack, but through sustained, managed withdrawal. The feeding mechanism begins with the mouth, a circular disc lined with keratinized teeth in concentric rings. When the lamprey locates a host, that disc locks onto the surface and the teeth begin rasping. They work continuously, grinding through the outer layers until blood flow is accessible. Then the anticoagulant enters the system.
What you need to say is instantaneous. Lamprey saliva chemically disables the host's repair sequence at the molecular level, so the wound cannot seal. The host has no mechanism to stop the extraction. The lamprey feeds for hours, sometimes days, attached to a host that is fully alive and fully unable to interrupt the process. Observe the life cycle context. The lamprey spends up to a decade as a blind larva before metamorphosis rebuilds the entire system for a single function: parasitic extraction. A lamprey that kills its host immediately loses the resource. The system is calibrated to extract without destroying. Now, imagine a fisherman pulls up a snapper, pries the mouth open, and sees a gray, armored body with 2 black eyes and legs pressed flat against the tissue. Not a tongue. Same size as the tongue, just not a tongue. That is Cymothoa exigua, and it has been in there functioning for up to 3 years.
A juvenile louse enters the host fish through the gill cavity. This is not a violent intrusion. There is no signal sent to the host's threat response system. The louse simply enters and matures. Once it reaches maturity, it migrates forward into the oral cavity. It positions itself on the tongue.
the basiohyal structure, and begins a controlled decommissioning of the tissue. This is not random feeding. It is a surgical strike on the tongue's blood supply. The louse uses its frontal claws to systematically starve the tongue of blood, killing the tissue in controlled stages. It's not blunt trauma. It's a managed decommissioning of the host's hardware. The host fish is now missing a tongue. Here is where the mechanism becomes structurally significant. The louse does not leave. The louse's 7 pairs of legs anchor into the remaining musculature of the tongue stub, not surface attachment, but integration into the tissue itself. It occupies the same spatial position the tongue previously held and transitions from parasite to functional prosthetic. The host fish continues feeding. Food passes through the oral cavity, the louse guides it toward the throat, and in return, the louse feeds on blood and mucus. The host is fully operational, anatomically altered, completely unaware the system has been replaced. This arrangement persists for up to 3 years. The horror of Cymothoa exigua is not that it kills, it is that it doesn't need to. It installs itself in a component's place and operates the host from the inside for years without triggering a single biological alarm. A shark kills once. The louse is still running the same host 3 years later.
Run all 3 against the shark simultaneously. Shark, 1 strike, 1 outcome. Host survivability near 0. System resets. Fringehead, 0 lethal events. Territory held indefinitely. Lamprey, 40 pounds extracted through sustained withdrawal. The system calibrated to prevent termination. Louse, lethality rate near 0. The same host still operational 3 years later. The shark's resource is gone. The louse's resource is still running. We call all 3 predators because we do not have a cleaner label, but what they are running is not predation. It is resource management. The organisms that outlast everything are the ones you never identified as threats until the system was already running. Subscribe to Apex Vault for more breakdowns from the analytical side of biology, what actually runs the system before anything registers as a threat.